Hello everyone. In this video we're going to be solving a nice Diophantine equation, which means an equation with integer solutions. We have a plus 3ab plus b equals 23, and we're going to find the value of a plus 2b. 2b or not 2b. Alright, so we're going to go ahead and solve the first equation and then find the a and b values and then plug those in. And obviously there could be multiple values for a plus 2b. And I'm thinking about presenting kind of like two methods, I guess we could say that. Let's go ahead and take a look at the first one first. I have a plus 3ab plus b is equal to 23. Great. Now, I have two variables and a single equation because we're looking for integer solutions. That's why these equations are called Diophantine equations, referring to the Greek mathematician Diophantus. So, we're going to be using some interesting properties of numbers, and sometimes we use what is called factoring. And in this problem, we're going to use factoring. And there's a couple different ways to factor this expression. We could also look at some alternative ways to approach this problem. Anyway, so let's see how we can work with this. Now, I noticed that a and 3ab go well together because they have a common factor, but 3ab and b also have a common factor. So we kind of need to start somewhere, and I usually like to start with the product. So I'm going to go ahead and write this first. Just kind of switch these around. And then look at different ways I can factor this expression. First of all, focus on the first two terms. If I factor out an a, I'm going to be getting 3b plus 1 plus b equals 23. Is that going to help? Kind of. Because the problem, it might help you, but the problem with that is I don't have 3b. That follows this. I have 1b. But I want to get the same terms. I want to get a common factor. So it wouldn't be nice that if I had a 3b instead of the b here. So can I just secretly insert a 3 there? No, I can't do that. But there's a way to take care of that. So here's what we're going to do. We're going to go ahead and multiply the original equation by 3 first. And the goal is certain. We want to get 3b. Okay, great. Let's go ahead and do it. Forget about this. This was just an observation. And let's go ahead and multiply both sides by 3 first. So that's going to give us 3 times 3ab plus, or I can just directly do it. That's fairly easy. 9ab plus 3a plus 3b is equal to 69. Great. Now, I should be getting what I need, but notice that previously I had factored out a 3a, so I'm going to stick to that. Because if I take out a different number, then it's going to be obviously a different story. So here's what I'm going to do. I'm going to go ahead and take a 3a outside, and that's going to give me 3b plus 1, and then this is followed by 3b. But I'd like to get a common factor, so let's add 1 to both sides, and that gives us 70. Awesome. Now, what am I getting from here? This means 3a times 3b plus 1 multiplied by 1 times 3b plus 1 equals 70. Awesome. Now we can go ahead and factor out 3b plus 1, and that is multiplied by 3a plus 1, and that gives us 70. So here's what it comes down to. I have the product of two integers because a and b are integers. These are integers as well, and their product is 70. So there's so many ways you can factor 70, and those are going to be like 1 and 70, 2 and 35, 5 and 14, so on and so forth. Let's go ahead and take a look at different options. For example, 1 times 70, 2 times 35, 3, 4 doesn't go, 5 times 14, obviously 6 doesn't go, 7 times 10, and there's nothing between 7 and 10 actually that can go into 70. That means, we're done. And of course you can switch them around, but that just means a and b values would be switched because of symmetry, so we don't have to worry about it. Let's just find the a, b values, and then we can switch them around. But these also come with their negatives, right? We have the negative 1 times negative 70. We have the negative 2 times negative 35. And then we have the negative 5 and the negative 14, which also gives us a positive 70. And finally, negative 7 and negative 10. So there are basically 8 ways to factor 70 into two factors if you don't consider permutations. Okay? So now, here's what we're going to look at. Suppose this is 1 and this is 70. Is that going to work? And the answer is yes. Why? Because if you set them equal to 1 and 70, you're going to get B is 0 and A is 23. Because 3 times 23 is 69 plus 1 is equal to 70. Great. So 23, 0 seems to be working. But are we going to go through every one of these like that? Well, there's an easy way to eliminate the bad ones. How do you eliminate the bad factors from the good ones? Well, take a look at this. 3a plus 1 from a number theoretical standpoint is 1 more than a multiple of 3. So if I subtract 1 from any of these factors, that must be a multiple of 3. If not, we'll discard it. And even if one of them fails, it's done. Okay? 1 and 70 passes because if I subtract 1 from each, it's good. That's a good pair. 2 and 35, subtract 1, right away you notice a non-multiple of 3, too bad. Subtract 1, bad. Subtract 1, 6 and 9, that's a good one. Negative 1 and negative 70. Subtract 1, you're going to get negative 2, that's a bad one. Subtract 1, negative 36 and negative 3, that's a good one. Subtract 1, negative 6 and negative 15, that's a good one. And subtract 1, negative 8 is not a good one. We can go ahead and cross the bad ones because we don't need them anymore. And we end up with 1, 2, 3, 4. So half of them are good, half are bad. Let's go ahead and take a look at each one. And remember, our goal is to solve for what? A plus 2b. Okay, a plus 2b is what we're looking for. So I'm just going to go ahead and do the following. I'm going to look at a factor, all right? And then, oh, by the way, I said that because of symmetry, we're going to switch them around, but that's going to change the a plus 2b value, wouldn't it? Well, actually, not really, because anyways, we'll see what happens. I just couldn't think of it right now. Now, 1 and 70. So here's what you can do. Subtract 1, divide by 3. That's how we get to a and b values. And suppose the first one is 3a plus 1, even though I wrote the 3b plus 1 first. That was kind of wrong, because I should always go in alphabetical order. But anyways, I forgive myself for that. Subtract 1, divide by 3. So that's going to give us the AB value. So let's go ahead and make a table. How about this? We can make AB and then A plus 2B table, and then just continue this. Once you get the idea, the rest will be trivial, right? Okay, let's go. Let's make a couple rows, and then hopefully you'll get the whole idea from here. Now, if I subtract 1 from each one of these and divide by 3, I'm getting 0 and 23, right? 0 and 23. Again, I'm using the opposite of this, by the way. Okay. A plus 2b, that's going to be 46. Great. And then I'm going to look at the 7 and 10. That's going to give me 6 and 9, which is 2 and 3. That's going to give me 2 plus 6, which is 8. And then I'm going to be looking at, so these are done. Negative 3, negative 1, and negative 12. Negative 1 and negative 12. A plus 2b is going to be negative 1 plus negative 24. It's going to be negative 25. And then I'm done with this. And finally, negative 6, negative 2, negative 5, negative 2, negative 5. That's going to be negative 2 plus negative 10, negative 12. Okay. So these are going to give me the values. What happens if they switch around? Obviously, you're going to get a different answer. Look at this. 23, 0 is going to give you A, 23 plus 0, which is 23. So you're going to get different values, yes? So we kind of need to keep doing this. But you get the idea. Hopefully, you can do this. Let me quickly talk about the second method because we're about to finish. All right. So the second method is kind of very similar to the first one, except it doesn't multiply both sides by 3 initially. So here's what I'm going to do. When I take out an A, remember, I wrote this first, right? When I take out an A, I notice I'm getting a 3B plus 1, but I don't want that. So since I want to get a B in the inside the parentheses, I want to take out a 3A instead. Instead of A, I can just take out. Can't I? Of course you can. You can do anything you want. So this is going to give me B plus 1/3, and then I get a B, but I should add 1/3. Oh, we're going to have to deal with fractions. Okay, not too bad, because this will be eliminated. So now this is 1 times that, so 3A plus 1, B plus 1/3 is going to be 69/70 over 3. Multiply both sides by 3, and guess what? You're going to get the exact same equation and proceed as before. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.